Okay, now we are going to start with limit of x tends to infinity. Let's see this. When limit tends to infinity. Now when limit of x tends to infinity, any number divided by x is 0. So when you have a sum of this type, what you have to do is you have to try to make sure that you get an x in the denominator, x or any indice of x. Let's see how do we do the sum. Let's take up a sum. Limit of x tends to infinity, 2x cube plus 5x minus 7 upon x plus 4, 2x minus 1 and 3x plus 5. Now when you get a sum like this, the first thing that you have to do is you have to check which is the largest indice of x. The largest indice of x is x cube, right? The largest indice of the variable is x cube. So you divide numerator and denominator by x cube. If I divide numerator and denominator by x cube, I'll get limit of x tends to infinity, 2x cube plus 5x minus 7 divided by x cube upon x plus 4, 2x minus 1 and 3x plus 5. Now see how I divide this by x cube. I need 3 x's, I am writing them separately. Split the numerator. If I split the numerator, this is limit of x tends to infinity. This is 2x cube upon x cube plus 5x upon x cube minus 7 upon x cube. Similarly, in the denominator also split the numerator of that term. So this will be x upon x plus 4 upon x, 2x upon x minus 1 upon x, 3x upon x plus 5 upon x, x cube gets cancelled, 2 plus, this is going to give you x square in the denominator. I told you a number divided by x in the denominator, x or any form of x. Say if I say x raised to m, right? X or x raised to n or x raised to any other number, say a. Any term, any constant term, the value is going to be 0. So that means this term will be 0 because I have a x in the denominator. Again I have x in the denominator, therefore the term becomes 0. X upon x 1, 4 upon x 0, 2 minus 1 upon x 0, 3 plus 5 upon x 0. So the answer is going to be 2 upon 1 into 2 into 3, that's 1 upon 3. So the basic thing is that the basic rule that you need to remember is that when you are dividing, you have to make sure that you have x in the denominator. Right? Whenever you have infinity, divide by x to leave a x in the denominator so that you get a 0. Right? Let's see another sum. Limit of x tends to infinity, 3x plus 2 upon root of x square plus 3 plus root of x square plus 1. Right? The highest index of x is 1. So I'm going to divide numerator and denominator by x. So limit of x tends to infinity, 3x plus 2 divided by x upon root of x square plus 3 plus root of x square plus 1 divided by x, right? So in this case, this is going to be limit of x tends to infinity. This is going to be 3x upon x plus 2 upon x. Now, this is going to be root of x square plus 3 upon x plus root of x square plus 1 upon x. Now when I take this x under the square root sign, this will become x square, right? This can be written as limit of x tends to infinity 3 plus 2 upon x. If I take the x inside the square root sign, this will become x square upon x square plus 3 upon x square. I'm taking it inside the square root sign and I'm splitting the numerator. The same thing I'm going to do here. This is x square upon x square plus 1 upon x square. This cancels. So now this is going to be 3 plus 2 upon x is 0. Square root of 1 plus 3 upon x square is 0. Square root of 1 plus 1 upon x square is 0. That's 3 upon root of 1 is 1. Root of 1 is 1. So this is going to be 3 upon 2. Right? Let's move on to the next sum, guys. Limit of x tends to infinity root of 5x plus 1 root of x plus 3 minus root of x plus 1. Now the problem in this sum is that it does not have a denominator. If it does not have a denominator, how do I divide by x? So for which what I'm going to do is I'm going to rationalize the numerator so that I get a denominator. So this is going to be limit of x tends to infinity root of 5x plus 1 x plus 3 root x plus 1 root. I'm rationalizing the numerator, right? Rationalizing means I'll have to multiply with x plus 3 plus root of x plus 1 and divide by the same term. Root of x plus 3 plus root of x plus 1. So I'm rationalizing the numerator. I'm leaving this term out and I'm rationalizing this term. This is going to be limit of x tends to infinity root of 5x plus 1 a minus b a plus b. So this is going to be a square minus b square upon root of x plus 3 plus root of x plus 1. Now here divide numerator and denominator by root x. So limit of x tends to infinity, this is 5x plus 1 upon x. I have divided by x. Now this bracket is going to be x plus 3 minus x minus 1. If I open the bracket, upon, I'm going to divide each term by x. So this is going to be root of x plus x upon x plus 3 upon x plus x upon x plus 1 upon x. Right? Now this can be written as limit of x tends to infinity. This is going to be 5x upon 5. 5x upon x, so that is 5 plus 1 upon x. This is plus x minus x gets cancelled into 2 upon root of 1 plus 3 upon x 1 plus 1 upon x. This is 2 as it is. Root of 5 plus 1 upon x is 0. Root of 1 plus 3 upon x is 0. 1 plus 1 upon x is 0. So in that case this is going to be 2 root 5 upon root 1 is 1. Root of 1 is 1. So answer is going to be root 5. This finishes the infinity type.